Welcome to the polynomial theorem video. Enjoy.
The rational root theorem. If px equals an xn plus an minus 1 xn minus 1 plus a1x plus ao, the factors of an, which is the leading coefficient, and ao, the constant term, can help you factor px and solve equation px equals o. So this is the equation. You have possible rational roots, which is px equals factors of the constant term, which is ao or p, over factors of the leading coefficient, which is an or q. And in order to fully solve this, you need to be sure that the fraction is in reduced form. So this is an example of the rational root theorem. So as you can see, we have our equation 12x cubed plus 3x squared minus 10x plus 36. So we can use the rational root theorem and put our constant, which is 36, over our coefficient, which is 12. And from that, we can put up this huge fraction right here, where we can find all of the possible roots, positive and negative, of this equation. So this is the conjugate roots theorem. So the first one is what you would use for rational roots, which is if p of x is a polynomial with rational coefficients, then rational roots of p of x equals 0 that have the form a plus the square root of b occur in conjugate pairs. That is, if and only if a plus the square root of b is an irrational root. Now what that means is the conjugate pair would be a minus the square root of b. As for imaginary roots, if p of x is a polynomial with real coefficients, then the complex roots of p of x equals 0 occur in conjugate pairs. That is, a plus bi is a complex root, then a minus bi is also a complex root. So these are some conjugate root examples. The first one is for imaginary. So as you can see here, it says a polynomial has 4 roots. 4 square root of 3, 8i, square root of negative 9, and 8 plus 4i. Find the other roots. So basically all you have to do is, since it's using the conjugate root theorem, you just have to find their conjugate pairs, which, as you can see here, we have done. For the second one, you have to find a 4th degree polynomial function, y equals p of x, with rational coefficients so that p of x equals 0 has roots negative square root of 7 and negative 3i. So basically you just have to find the conjugate pairs and multiply them all together, and then you will get x to the 4th minus 7x squared minus 9x squared plus 63i. This is the fundamental theorem of algebra. So basically, if p of x is a polynomial of degree n greater than or equal to 1, then p of x equals 0 has exactly n roots, including multiple and complex roots. So this is an example of how you would use the fundamental theorem of algebra. So it's 8,000 x to the 4th plus 6,597 x to the 3rd plus 4x squared plus x plus 5 million. It only has 4 roots, so those can be imaginary, rational, or irrational, and how you could know this is just by this right here. It's all you need to know using the fundamental theorem of algebra. Alright, so this is Descartes' rule of signs. So let p of x be a polynomial with real coefficients written in standard form. So the number of positive real roots of p of x equals 0, or less by an even number, equals the number of sign changes between consecutive coefficients of p of x. Same thing goes for the number of negative real roots of p of x equals 0, or less by an even number, equals the number of sign changes between consecutive coefficients, this time of p of negative x. And then count multiple roots according to their multiplicity. So this is the example for Descartes' rule of signs. So what does Descartes' rule of signs tell you about the following? X to the 4th plus 3x cubed minus 5x squared plus 10x minus 15 equals 0. So from this, we can immediately tell that there are 3 positive roots by seeing how many times the sign changes. So you got 1 time here, then you have another time right here, and then a final one right here. So from there, we know that there's 3 positive roots. And then in order to find how many negative roots there are, we multiply the whole thing by negative. And in doing so, we can find out that there are 3 negative roots as well.
Which through rule would you use for the following? A, B, C, D, E. And the following 1, 2, 3, 4, 5. Good luck.
Hey guys, if you want to try out the problem for yourself, go ahead and pause this video.
This is the correct answer for the quiz. Thank you.
Thank you for watching this video, and we hope you enjoyed.